40 light-years away, nestled in the constellation Cetus, lies a celestial object that has captivated the attention of astronomers, LHS 1140b. This distant world, an exoplanet orbiting a red dwarf star, was initially classified as a Mini-Neptune, a gaseous giant slightly smaller than Neptune. However, recent observations have challenged this assumption, suggesting that LHS 1140b might belong to a more intriguing category, super-Earths. The possibility of LHS 1140b being a super-Earth has ignited excitement among scientists. Super-Earths, as their name suggests, are rocky planets larger than our own. They represent a class of celestial bodies that are not found in our solar system, making them particularly alluring for study. The prospect of a super-Earth orbiting a nearby star presents a unique opportunity to delve into the mysteries of planetary formation and the potential for life beyond our own planet. The quest to unravel the true nature of LHS 1140b has only just begun. The James Webb Space Telescope, with its advanced instruments and unparalleled sensitivity, is poised to play a pivotal role in this endeavor. By studying the planet's atmosphere and surface, scientists hope to determine its composition, temperature, and potential for hosting liquid water, the elixir of life as we know it. To understand LHS 1140b, we must first delve into the realm of its host star, LHS 1140. This star, classified as a red dwarf, is considerably smaller and cooler than our Sun. Red dwarfs are the most common type of star in the Milky Way galaxy, outnumbering stars like our Sun by a significant margin. Their diminutive size and low luminosity mean that their habitable zones, the regions around a star where temperatures are suitable for liquid water to exist on a planet's surface, are located much closer in than the habitable zone of our solar system. LHS 1140, while smaller and cooler than our Sun, is known for its relative stability. Unlike many other red dwarfs, LHS 1140 exhibits relatively few flares, sudden bursts of energy that can be detrimental to life as we know it. This stability makes LHS 1140b a particularly interesting target in the search for habitable exoplanets. Planets orbiting red dwarfs are often tidally locked, meaning that one side of the planet perpetually faces the star, while the other side remains in perpetual darkness. This can lead to extreme temperature differences between the two hemispheres, potentially affecting the planet's habitability. The study of red dwarf systems, such as LHS 1140 and its enigmatic planet, is crucial for understanding the diversity of planetary systems in our galaxy. While red dwarfs are the most common type of star, their low luminosity makes them challenging to observe. However, advancements in telescope technology such as the James Webb Space Telescope are enabling astronomers to study these systems in unprecedented detail, shedding light on the potential for life in the vast expanse of the cosmos. Initial observations of LHS 1140b, conducted using ground-based telescopes, suggested that it was a Mini-Neptune, a gaseous planet with a thick atmosphere composed primarily of hydrogen and helium. Mini-Neptunes are thought to be common in the galaxy, but their large size and gaseous nature make them unlikely candidates for harboring life as we know it. However, as astronomers delved deeper into the data, inconsistencies began to emerge, hinting at a more complex and intriguing reality. The first clue that LHS 1140b might not be a typical Mini-Neptune came from measurements of its density. Despite its relatively large size, LHS 1140b was found to be significantly denser than expected for a Mini-Neptune. This suggested that the planet might have a substantial rocky core, potentially surrounded by a layer of water or ice. The possibility of a rocky planet with a potentially significant amount of water immediately piqued the interest of scientists searching for signs of life beyond Earth. The unexpected density measurements prompted astronomers to re-evaluate their initial classification of LHS 1140b. Could this seemingly ordinary Mini-Neptune orbiting a faint red dwarf star actually be something far more extraordinary? The answer, it seemed, lay in a deeper understanding of the planet's atmosphere, a challenge that would require the advanced capabilities of the James Webb Space Telescope. To peer into the atmosphere of a distant exoplanet, astronomers employ a technique known as transit spectroscopy. This method relies on the fortuitous alignment of a star, its planet, and Earth. When a planet passes directly between its star and Earth, an event known as a transit, a tiny fraction of the star's light is filtered through the planet's atmosphere. By analyzing the spectrum of this filtered light, astronomers can identify the chemical fingerprints of the gases present in the planet's atmosphere. In the case of LHS 1140b, astronomers turn to the James Webb Space Telescope's near-infrared imager and slitless spectrograph (NIRISS) instrument to conduct transit spectroscopy observations. NIRISS, with its ability to observe in the near-infrared portion of the electromagnetic spectrum, is particularly well-suited for studying the atmospheres of exoplanets. The near-infrared region contains numerous absorption features, or dips in the spectrum, that correspond to specific molecules, providing a wealth of information about the composition of a planet's atmosphere. The nearest observations of LHS 1140b were eagerly anticipated, as they held the key to unraveling the mystery of the planet's true nature. Would the spectral data confirm the initial classification of LHS 1140b as a mini-Neptune, or would it reveal something entirely unexpected? The answer, as it turned out, would challenge the prevailing assumptions about this distant world. So, let's talk about mini-Neptunes for a moment. These are planets that are, well, larger than Earth, but smaller than Neptune. And they have thick atmospheres filled with hydrogen and helium. Now, the thing is, scientists have been debating whether these planets could support life. And honestly, it's not looking too good. The thick atmospheres create high pressures and temperatures, making it pretty challenging for life as we know it. Plus, their atmospheres might be too dense, blocking out the light necessary for photosynthesis. So, yeah, mini-Neptunes might not be the best candidates for habitability. But hey, the universe is vast and full of surprises. There are so many different types of planets out there, and each one presents a new possibility. Take super-Earths, for example. These are planets that are more massive than Earth but less massive than Neptune, and well, some of them could have the right conditions for life. Then there are the so-called water worlds, planets covered in deep oceans. Imagine the kinds of life forms that could evolve in such environments. And let's not forget exomoons, which are moons orbiting planets outside our solar system. These could also potentially harbor life. So, while mini-Neptunes might not be great candidates, there are plenty of other worlds out there that could be teeming with life. Hycean worlds, a fascinating blend of hydrogen-rich atmospheres and vast oceans, have captured the imagination of scientists. These planets, larger than Earth but smaller than Neptune, could potentially harbor life. But what makes them so intriguing is their unique combination of conditions. Understanding the atmospheres of Hycean worlds is no small feat. Scientists use advanced telescopes and, sophisticated models to piece together the atmospheric composition. By studying the light that filters through these atmospheres, they can, identify the presence of various molecules like water vapor, methane, and even potential biomarkers. The search for life on Hycean worlds is a quest filled with challenges and excitement. Researchers, they are meticulously analyzing data, looking for signs that could confirm the presence of life. This involves, sifting through vast amounts of information and ruling out false positives. It's a meticulous process, but the potential rewards are, without a doubt, worth the effort. The study of Hycean worlds represents a significant stepping stone in our exploration of exoplanets. Each discovery, brings us closer to understanding the vast diversity of planets in our galaxy. And who knows, maybe one day these mysterious worlds will reveal secrets that change our understanding of life in the universe.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.